Hello everyone, welcome to Calculus 3. This is a section 2.1, vectors in the plane. So let me introduce you vectors first. So vectors, it's a quantity that magnitude with a direction. All right, so magnitude means it's length. And we have a line segment here. So we have this figure, right? And we have this figure. This is a P, and this is a Q. So we call this is initial point. We call this is a terminal point. All right, so initial means starting point, right? All right, so we denote this line segment this way, right? P, Q. So this is initial. This is terminal. Hey. Which is ending point, right? So this will be vector notation. So we are using one letter, which is vector V. So we are using volt, and not the vol, bold, correct? Volt. Or we can use two lines, two arrow. So vector V or one arrow on the top is a vector V. Yeah. So this is a vector notation. All right. So vector is magnitude. Magnitude means it's length with a direction, right? So it can be this direction, it can be that direction, it can be that direction. So in real life, we are using south, north, I did the south, north, east, west. That kind of a notation, we are using that for direction, right? So magnitude, length, which is speed, we can say that 60 miles toward to the south, 70 miles toward to the north, right? So that is the vectors. Okay, now they said in 2.1, vectors in the plane. What's the in the plane means? It's a two dimension. So we had XY plane, right? So let me write down here, plane means XY plane, XY. So think XY plane. Otherwise, we say the Cartesian coordinate system, right? Spell Cartesian coordinate system, which is two dimension. So we denote like 2D dimensions. One dimension, we know that number line, right? So this is X, right? So number line. We start to 0 and goes this direction positive, 1, 2, 3. This direction negative, right? So this is one dimension. All right. So we understand what is a vector means and then what is in the plane, right? Okay. Then let's do this one. Equivalent vectors. Where's my... Okay, so equivalent vectors, they said if they have the same magnitude and the same direction. So magnitude, we just introduced the vocabulary length. So basically same length with the same direction, we say the equivalent vectors. So it can be same direction, oh, same length, right? Yeah, they are equivalent vectors or a little bit longer, looks like. Just a little bit, right? So let me delete a little bit. Yeah, so they are equivalent vectors. All right, now we have a sketch a vector in the plane from initial point P coordinate 1 and 1 and to terminal point Q 8, 5, right? So this is X, this is Y, right? So X, Y. So P1, 1, this is a point order pair, right? So 1, 1 there. And then Q, 8, 5. So 1, 2, 3, 4, 5, 6, 7, 8. This is 8. Let me write that one. 1, 5. This is a 5. So Q here, A5, right? So initial point P, terminal point A5. We plot the point and we connect and then make an arrow. Then we are having line segment PQ, right? We are using vector notation, vector V, just the first letter vector V, and vector notation, right? So I did not mention that. We are going to use this notation as a vector because this is a more step. This is a one. I don't lift the pencil, right? So this is more easier to writing. This is symbol. Okay? So this is how we sketch a vector. All right. Now then, how do we indicate other vectors, right? All right. So in general, we have let's say the vector V here. Yeah. Okay. 2 times of vector v, then I want to measure twice of them, right? Oh, I think I make it bigger at first. I think this is the one. Do you think so? So 2 times of vector v, yes? Approximately, right? How about 1/2 of a vector v? That means make it shorter, right? So let me write down here. How about that? Is it? Yeah, 1/2. Okay, how about the negative, right? So negative. All right, so negative vector v, we can express this one as -1 of vector v, right? Then we are using the negative. It's the same length because vector is quantity that has magnitude with the direction, right? So magnitude, we keep the same magnitude, but then we have a negative, so with the opposite direction. So let me write down. No, means opposite direction. Okay, so how about this then? Yeah, copy. This one, I will use and this is a little bit tail off. Yeah, because I erase. Okay, then we can say that by experience just now, right? So if we have a vector v, we have some numbers in front of the vector v, right? Let's say the k in general, right? So k. Then we called this one is scalar. This is a scalar. Scalar, no. Scalar. Scalar. So scalar means real number. So for example, we have like 2, 1/2, -1. Those are scalar, right? So we can express 3, 5, 7, any numbers, right? So scalar means any number, real number, right? Okay, then we just have that if k is greater than 0, means that positive. Let me write down here. Number 1, if k is greater than 0, think positive. Then same direction of vector v. If k is less than 0, then think negative, right? Then what's the direction? It's opposite direction, right? Then opposite direction of vector v, right? And if k equal to 0, then the vector v will be 0 vector. So we have this notation is 0 vector. So that means 0 vector means no magnitude with no direction, right? Means no magnitude with no direction. Okay, so let's talk about the vector sum, vector difference. So vector sum. So let's say that we have a vector v like that. Okay, so this is initial. So this is the initial, right? Vector v. And let's say that this is vector w. We connect from initial of vector v to terminal of vector w, right? We connect. Then from initial to the terminal, right? So that is the sum of vector v and w. So we are using this is like a triangle method. Triangle method. So think, connect to from initial of vector v and terminal of vector w, right? Other textbook they using this way. So tail and tip, but tail and tip a little bit confusing. Some textbook indicate the head and tip. But I think initial and terminal is the more sense and then less confusing word, right? Is it okay? We have parallelogram method. So the parallelogram method looks like this. So we have a vector v start with, and then the initial share with vector w, right? Can you see that different way? So in that case, we have the top one has the triangle method. The initially start with a vector v, and then from terminal of a vector v start with a vector w, right? But the bottom one has start with a v and then share the initial with a vector v with a w, right? So like that, right? Then we can make a parallelogram from there. I'm not good at that, so let me do that. Yeah, parallelogram looks like rectangular, right? So that will be vector V plus W, right? So this is a parallelogram method. Okay. How about vector difference? Vector difference. So vector difference, we have a vector V here, and then vector W. Can we see that the pointing, I'm using pointer here. Can you see that we have a sharing initial point right here? If we want to make addition, so we are using the diagonally make a parallel method, right? So we cannot make a parallel to using that. That's the addition, right? So we want to make a difference, but they are sharing the initial point, right? So we can just connect. That is a vector difference. So that will be from V to the, I'm sorry, vector W to the V, and then that from the initial will be W to the vector V, right? So there's a VW, I'm sorry, vector V minus vector W, all right? So let me write down, think, connect, spell, frustrating, connect from terminal of vector W and let me write down W and terminal of vector V. All right. Okay. Now, another way. So we have a vector V here, right? And then vector W, we can use opposite direction, right? So opposite direction, how about this way? How about, let me write down this one here. Here. And then opposite direction will be this way, W. Yeah. Okay. Then we connect from this time here to there, right? So there will be V plus negative W, right? Same as. Is it okay? Because we are using this one as the opposite direction of, right? So I don't have to write down. So let's just sketch the vectors. Sketch the vectors 2v minus w. Okay, so let's say that v is here. Let's say that w is here, right? Okay, 2v, so 2v, and let's say the v, I'm sorry, w. We just connect, right? We had experience earlier. So I am using this one, this method, right? So that will be two v minus w, right? Okay, how about other method, right? So we have 2v and w, so opposite direction. This is negative v, right? I am very sorry, I did not mention that negative v, right? So negative v, yeah. So negative v. And then we connect from initial to terminal, right? So there is 2v plus negative vector w, right? Oh, you cannot see well. All right, so how about that? All right, so we introduced earlier equivalent vectors. So let's do that. Okay, so equivalent vectors, they must have the same length, same magnitude, and same direction, right? Think same magnitude with same direction. All right. So vector v has initial point 0, 0 and terminal point 1, 1. And negative 2 and 2 for the initial, and then terminal point negative 1 and 3. Okay, so the red, I indicate that that's the vector v, and then w vector w, right? W vector w. So this is the vector v, initial 0, 0. So this is 0, 0, and then 1, 1. And this is the initial negative 2 and 2. And this is negative 1 and 3. That's the terminal point, right? Okay, so how do we conclude? It is equivalent to vectors because they have the same magnitude and same direction. We can see easily, right? Okay, now we have the terminology, standard position vector. Okay, so we have a standard position vector. So vector with its initial point at origin. So means that initial point at 0, 0, right? Then we get vector which is component x and y. Just a general definition, right? I mean general form of standard position vector, right? So 0, 0. So initial point is 0, 0, terminal point xy, right? Or any number, right? So 2, 3, 7, 5, and so on, right? And then I just said the component, right? That's another terminology in vector. So we have component form of vector. So let V is the initial point. So we are using order pair as a point, right? In 2D in the plane, right? So X, Y. So we are using I, sub I, read, read, X sub, subscription I. Then we read Y sub I, right? And terminal point, they're just using T from the first letter, T, right? So I from the initial I, right? So X sub T, Y sub T, right? Okay. Then how do we find the vector from the 2 point, right? X sub T minus X sub 1 for first component, Y sub T minus Y sub 1 for second component, which is XY, right? So we have here X sub XY, not the X sub Y, X and Y, right? So I denote earlier component. So this is a vector notation. We have order pair. This is order pair, right? Ordered pair. And this is a vector notation. So people called this is triangular bracket. Triangular bracket. Like we have a curly bracket, right? And square bracket. So normally we read square bracket, just bracket, right? We don't put the square, right? So square bracket, triangular bracket. Yeah. So this is a vector, right? So basically we have a vector from 2 points, right? Okay, let's calculate this one. Express vector V with initial point, -3 and 4, and terminal point 1 and 2 in component form. Then we have to make a vector notation triangular bracket, right? That's the component form. Okay, then we just using the formula, which is that, right? So let me bring this one. Okay, so I denote here, this is X sub T, Y sub T. So there will be X sub T, which is 1, X sub 1, X sub I, which is -3, And y sub t, which is 2, minus y sub 1, which is 4. Then what do you get? So we have 4 and negative 2. Is it correct? Okay. So that's it. This is easy, right? All right. So let's talk about the magnitude. How do you find the magnitude? So we have a vector v, magnitude, vector v. Yeah, so we denote two line, two vertical line. So one line is the absolute value, right? So we have two lines. So that is magnitude of a vector v. Then we have v equal to component form of a vector, which is x and y, right? Because those number from the two order pair from the x and y, right? That's why they're using just the x and y there, right? And we have the formula. How do we find? This is from the distance formula, okay? So that will be x squared plus y squared. Yeah, same as, right? So think about the distance formula. So magnitude, we know that the length, right? So length. Okay, then let's find the magnitude of a previous one. Before that, let me write down if magnitude equal to 0. Let me write down this one first. 0. Not the 0 vector. If only if only. This means if only any, right? If only and if, 였나? I'm sorry. Speak Korean. If only if. Yeah, anyway. This means we go to this direction, make a true statement. If we go to this direction, also true statement. I'm crazy right now. Okay, that means if magnitude equal to 0 means the vector v equal to 0 vector. All right. Okay, so let's find out quickly. So we want to find out vector v, then let me write down this one. Ooh. So vector v from the above, we have a 4 and negative 2. Then that will be 4 squared plus negative 2 squared. So 16 plus 4, which is square root of 20, right? Oh, you cannot see. Sorry about that. Is it okay? Now we have some definition. So here. So vector v, we have a component notation, right? And then k is the scalar. Scalar means any real number. So we have a scalar multiplication. So K is a scalar, and we times with vector V, then we distribute. So we get the component of a vector kx sub 1 and ky sub 2, right? And then we have a vector addition. We have two vectors, and we add together. Then we add x component with the x component and y component with the y component, right? So we have a vector x sub 1 plus x sub 2 and vector notation with y sub 1 with y sub 2. So let's do example. Okay, so here's example vector v with initial point 2, 5 and terminal point 8, 13. And vector w is already in component form, right? Okay, so we want to find vector v in component form and find the magnitude of vector v, right? Okay, so let's do that. The vector v equal to the formula said x sub 2 minus x sub 1, y sub 2, minus y sub 1. So x sub 2, which is a minus 2, y sub 2, which is 13 minus 5, which is 6 and 8. And magnitude, which is x squared plus y squared, which is 6 squared plus a squared, which is the square root of 100 equal to 10, right? Is it correct? So you should check it out, right? Okay, second part. So we want to add vector v and w. That is x sub, I don't want to get confused, right? How about I want to make a v sub 1. I don't want to confuse. So how about not vector, just component, right? So v sub 1 plus w sub 1 and v sub 2 plus w sub 2. You guys understand what I'm saying, right? I don't want to get confused with the order pair. That's why I don't use that x and y, right? Yeah. Okay, so there will be v, we have 6 and 8, and w we have a negative 2 and 4. Yeah, so that will be v sub 1, v sub 2, right? This is a w sub 1, w sub 2. Yeah. Okay, then that will be 6 plus negative 2 and 8 plus 4, right? So we have 4 and 12. Yeah. Oh, you cannot see. Sorry. Okay. See, 3 times over vector v. So 3 is a scalar, right? So scalar. So 3 times over v. V has 6 and 8. So we do distribute. So we have 3 times 6 and then 3 times 8, which is 18 and 24. The last one V minus 2 times of W, right? Okay, so 6, 8 minus 2 times of W. W is negative 2 and 4. So 6, 8 minus. Okay, so let's make a plus here and then give it to the negative inside. So negative 2 times negative 2 and negative 2 times 4. And 6 and 8 plus negative negative is positive and negative 8, right? Ooh. So we have a 6 plus a 4, 8 plus negative 8. Yeah. Okay, that will be 10 and 0 then. Yeah. Everything is okay? All right. Now we have a theorem. So let me make a copy and paste from the note because too long. Okay, so here is a theorem 2.1 properties of a vector operation. So we have vector u, vector v, vector w, and RS or scalars. So scalar means real numbers, right? Any real numbers. Okay, then, oh, we have addition is commutative, and then addition is associative, and we have additive identity, which is 0, and we have additive inverse. So they are additive inverse each other. And then we have associative scalar multiplication. So it means that we change the scalars, is still we get the same result. And then we have distributive distributive properties. So basically this is back distributive, right? And this is a front distributive, but we don't use a front, right? So we are using back distributive, back. And then we have identity and 0. So identity with the multiplication for this one. Ooh, I can't go. And we have a 0 in the multiplication, we get 0. Yeah. All right, so let's do example. Find the component form of vector with a magnitude 4 that forms angle of negative 45 degree with x-axis, right? Okay, so let's talk about trigonometry. So we have R, right? And we have triangle, theta, angle, theta, right? So x equal to r cosine theta, right? And y equal to r sine theta, right? Okay, so r we can express as a vector v. Excuse me. Yeah, the vector v has r is the length, so we make a magnitude. So like this. Yeah. Okay, then that will be vector v cosine theta, right? And that will be vector magnitude of vector v sine theta, right? All right. Now They say the magnitude 4, that means vector V, which is magnitude equal to 4, right? And angle of negative 45, how do we indicate that? Indicate that. indicate negative 45 clockwise, right? So if we have unit circle, then clockwise, that's negative 45 degree, right? Oh, too much, yeah? That's 90. That's the negative 45. Negative 45. Yes? Okay. Now, we want to express as a component form. So like a triangular triangular bracket, right? So we have a vector V. We have to make a x, y form. Now, x we can express as that r cosine theta, right? So let me do one by one. R cosine theta, y equal to r sine theta, and then r cosine theta we can express as a v magnitude of vector v cosine theta, and r sine theta as magnitude of vector v sine theta, right? Okay, now change the color. Magnitude of vector v, we knew that that's 4. What's the cosine? Negative 45 degree, right? You think 4 sine negative 45 degree, right? Okay, so that will be 4 is a quadrant 4. So it's a negative square root of 2 over 2. And 4 negative square root of 2 over 2. Then we calculate. Then that will be easy calculate, right? So that will be negative 2 square root over 2. And also negative 2 square root over 2. Yeah. Any question? Okay. Another terminology, unit vector. We learn a lot, right? Okay, so unit vector is a vector with a magnitude is 1 that has the same direction of a vector v, right? So we use u hat. When we see that u hat, that means unit vector, because we are using just the first letter unit u, right? As a u here, u hat, yeah? And then we have the formula. So 1 over magnitude of vector v times just vector v, right? So what this means, same direction of as a vector v. So vector v goes to this direction, then unit vector has the same direction. Make sense? All right. Let's do this example. So we have vector v. All right. Then find the unit vector with the same direction as the vector v. Okay. We are using the formula u hat copy. All right. So we want to know about the magnitude of vector v. So 1 over magnitude of vector v we had earlier. So square root of x squared plus y squared, right? So that will be 1 square plus 2 square and times vector v, which is 1 and 2, right? With a component. 1 square plus 2 square, which is 1 over square root of 5 times vector 1, 2, right? And then we do distribute. Then we have 1 over square root of 5 with the vector notation, right? And 2 over square root of 5, right? Okay. Now, can you check that whether the magnitude is 1 or not? Yeah, just check. How do you check? U hat, magnitude of U hat, which is square root of 1 over square root of 5 square plus 2 over square root of 5 square, right? Should be different. Okay, so 1 over 5 plus 4 over 5, 5 over 5, which is 1, right? Yeah, their magnitude is 1. And then which direction? Same direction with vector v, right? So vector v goes to this direction, go to the, you also go to this direction, yeah? Or this direction, go to the same direction of vector v. Make sense? Okay. Let's do second part. Okay, second part, find the vector w with the same direction as vector v, such that magnitude of vector w equal to 7, right? Okay, so we should understand this one. Like earlier we did a scalar with the vectors, right? So let me explain to you one more time. So we have a vector v earlier. We said that vector 2w, I'm sorry, 2v earlier, right? So double size of that, right? 1/2. And then half size, right? So look, from the vector v, I make a double size or half size, yeah? So they goes to the same direction. Can you see that? Same direction. So we say that this is a parallel, they are parallel vectors, right? Okay, so in that case, we have a magnitude w equal to 7. Then, and the direction is the same as vector v, then we had the same as vector v earlier, which is vector u, right? Vector u, unit vector. Unit vector goes the same direction with a vector v, right? Then we can just use scalar 7 and then vector u. Make sense to you? So let me write down. Think 7 unit vector of that. Yeah. Then we have 7. U was 1 over square root of 5, 2 square root of 5, right? Then that will be 7 over square root of 5. 7 times 2, which is 14, square root of 5, right? That is vector W. Make sense? Almost done. Please hang in there. Okay, standard unit vector. Okay, standard unit vector. So we had a standard vector earlier, right? So initial point at the origin, right? And then terminal point at some point. So here also standard means start at the origin. And then we have a unit vector. So earlier we had a unit vector means magnitude is 1 at the same direction with the vector, right? Okay. So we have standard, which is I unit vector. Then we have 1, 0. So look, I hat there, right? With I hat. Looks like wearing hat, right? So I hat. Okay, so 1, 0. This is 1, 0, right? So 1, 0. So this is a vector, so we denote this way, right? Vector. And 0, 1. So basically, I hat goes to this direction, x direction, right? And j direction goes to that direction, y direction. Can you see that? And start to origin 0, 0 to 0, 1. Yeah. Make sense? Their magnitude is 1. So we say the standard unit vector I hat, j hat. Yes? Okay. Then we have another terminology, linear combination. So linear combination, let me write down here, linear combination. So we have a vector v equal to xy. Then we can express this one as x0 plus 0y, right? Because this is, so do you agree or not? Yeah? You agree? Yeah? Because x plus 0, which is x, 0 plus y, which is y, right? Okay, now let's move on. Then we can express this one as x times 1, 0 plus y times with a vector 0, 1. We can distribute. Yeah, so think about that. Think about that. Yeah, we can distribute. Then we get x. This is 0. This is y. We get, oh, sorry, 0, y. Yeah. Do you agree? Yes? Okay, then think this way. We can have this one. 1, 0 with a vector is I hat. 0, 1 with this one is j hat. Yeah. Okay, then we can say that this one is x I hat plus y j hat. So this is a linear combination form. Another terminology. Make sense? All right. Now let's do example. Okay, so express the vector w equal to 3, -4. This is a vector component form, right? And then we want to express in terms of standard unit vector. So basically, like a linear combination IJ form. Yeah, standard unit vector IJ, right? And then linear combination also IJ form, right? So basically same thing, right? So we can say that W equal to the first component 3I, second component -4J. Yeah, that's a standard unit vector form or linear combination form, right? Let me just denote this way. Okay, second part. Okay, second part. Unit vector is a unit vector, yes. That form is angle over 60 positive x-axis. Use standard unit vectors to describe the vector u. So let's make this as a part then. And let's make a unit vector equal to x and y, right? So we had the experience earlier, x, which is, how about that? R cosine theta, so vector v cosine theta, right? And vector v, magnitude of vector v sine theta, right? So let me denote. Cosine theta, which is cosine theta. Ooh. Sine theta. Okay, with the vector notation. Ooh, okay. Then we know that the unit vector has the magnitude is the one, right? Okay. So we will get, then you might get confused. So let me write down the U instead of V. How about that, right? So 1 times cosine 60 degree. 1 1 times sine 60 degrees. So please think quickly. 1, 2, 3. What's the cosine 60 degree? 1/2 sine 60 degrees square root of 3/2. Okay, so this is a vector form. Component form. But we want to express a standard unit vector, right? So there will be 1/2 I hat plus square root of 3/2 j hat, right? So standard unit vector form or linear combination, right? Okay, last question. Thank you for your patience. Okay, so we have to understand this vocabulary before we do that application problem. So let me write down this one. Resultant vectors. Resultant vectors is sum of vectors. So we have an application. So this terminology for this application. So this is example 2.10. This is the last question in this section. Finding resultant velocity. Airplane flies due west. So I annotating means, this means negative, and then east is positive. At airspeed of 425 miles per hour, the wind is blowing from the northeast at 40 miles per hour. But in that case, they give us a hint. The wind is from the northeast, so it is blowing to the southwest. Yeah, so this is a southwest because I indicated this one here. Look, this is the east, this is the west, this is the north, south, then this is the northeast, northwest, southwest, southeast. Make sense? Okay. Now, what is the ground speed of airplane? Means that we have to find what's magnitude of sum of. I indicate the P as a, what was the P I indicated? The planes, the plane, airplane, airplane, and also windy. Yeah. So plane and the wind. Airplane and wind. What is the bearing of airplane? Means direction. We're gonna measure in degree because the original question is the degree mode, right? In angle. Okay, let's do it. So here, from here, right? So this is x-axis. That's why I made a negative. This is y-axis, right? So negative 425. I want to make a negative there. We want to make a negative, yeah? So, if we make this, and there's angle theta, there will be vector v, yeah. So there will be x, this will be y, right? Make sense? Okay, so let's do it. Planes velocity vector. So let's using the first letter P with a vector notation. Then airplane flies due west. West means negative. We talked earlier. Negative 425. I had. Yeah. And then plus 0 J hat, right? How about windies? Windies? Windows. Not the Wendy's. Oh, no. Don't get confused. Windy. Wind. Wind. Planes. Velocity. Vector. So W. Oh, you cannot see. XY. Yeah. Which is, look, R cosine theta. So instead of R cosine theta, we are using a vector V cosine theta and vector V sine theta, right? Oh, okay. Now, the magnitude, which is 40, right? And then cosine, look, here, 45 degree, right? 45 degree. So how do we calculate? So counterclockwise, 90, 90 plus 45. Here you go, right? Make sense? So we have a cosine 225 degree, and then 40 sine 225 degree, right? So far, so good. Okay. Now, so little triangle, let me bring down again, note, right? So vector V, magnitude, angle, x, y. So x, v, cosine theta, y, v, sine theta. Okay, so cosine 225, which is 45 degree in third quadrant. What do you get? Thank you. Negative square root of 2 over 2. And 40 sine, sine 225, which is 45 degree in quadrant 3. Also negative. Thank you. All right, calculate. We had the experience earlier. 20. So 20, negative 20 square root of 2, negative 20 square root of 2. This is a vector component form, right? And this is standard uniform, right? Uniform, unit vector form. So we call this is resultant vectors because we add two vectors, right? P and oh, let me fix that. W. So airplane with the wind, right? Okay. We want to know about the speed. Because they ask us, right? So that's the question, speed of airplane. So we want to know about magnitude of the airplane with the wind. So let me write down. Means speed of the plane. Okay, so I want to put in this one with this one, right? So I hat with the I hat, J hat with the Z hat, right? So let me make it clear for you. So negative 425 minus 20 square root of 2 square plus 0 plus negative 20 square root of 2 or minus minus 20 square root of 2 square, right? Okay, so let me think. I had term and J had term. Okay, so calculate 454.17 miles per hour. Did you get the same answer? Okay, how about bearing? Measure in angle, tangent, theta. Yeah, if we want to find the angle, right? So y over x, y direction, which is j, right? J hat, x direction, which is I hat, right? Okay, so we have j hat, so 0 minus 20. I just writing for you 0, okay? Otherwise you might get confused. I had negative 425 minus 20 square root of 2, right? Think J I. Yeah. Okay. Then we get this one is a point 0.0623. How they find the angle or tangent, right? So angle theta or tangent 0.0623. So that will be 3.57 degree. So this is south of west. They say so, right? They say this southwest, southwest. And also, we need to think about the domain of inverse of Okay, so thank you for watching. You have a nice day or nice evening. If you have a question, please let me know. Email me, text me. All right. Thank you very much. I will see you in the 2.2.